A very good afternoon to all of you. Today we will cover another lecture on of this course, that is by overview of WebGIS and application development. In the first lecture we have seen the overview of the geocomputation, and in the second lecture we have seen what are the various data sources which are useful for geocomputation. In the third one, we have gone through the Python programming language, how Python programming can be used for various kinds of geospatial applications, or how to develop a geocomputation based application. Now, in this in this series, we have a third lecture that is on the WebGIS. That is also very important component in the geocomputation, the latest one, wherein the GIS is being carried out over the internet. You can perform all those geocomputation tasks on the web itself. So I will be giving you a brief overview of the architecture of WebGIS and how to develop a small application of WebGIS. So the content of this session will be like I will be telling you about the definition of a WebGIS, client server architecture, WebGIS architecture, because whenever we are talking about the client about the WebGIS, so there is a concept of client and server. There are certain clients which are making requests to the server. So a small introductory slide will be there for the client server architecture and what are the various components of WebGIS. And then I told you in my previous lecture also there is a concept of web services. We are not utilizing the data directly. We are making use of the GIS data in the form of a web services. Now there is one special there is one international consortium agency by the name OGC which are developing these web services. And similarly, what are those standards which are being developed for the WebGIS like WMS, WFS, WCS, WPS, and what are the formats of the data exchange in the web environment? It can be a GeoJSON format, XML, or the KML format. Then we will have one huge small demo also, wherein we will be creating one WebGIS application through QGIS without the need of any programming background. You can also create a small WebGIS application. There are certain plugins which are available in QGIS. You can make use of those plugins as well to create your own WebGIS application. So that application then will be running over the browser. Once you have created your WebGIS application, then you can execute it on a internet browser like Google Chrome. It can be a Firefox, Mozilla, or Internet Explorer, anything, Microsoft Edge. On any platform, you can execute your application over there. Then we at IIRS we have developed one WebGIS application by the name called Forest Fire Risk Advisory and Monitoring System. So I will be giving you a live demo of a small about this application as well, this WebGIS application. So when we talk about definitions of WebGIS, so to be very simple, by the name itself, it says that the GIS over the web means if you are able to execute your GIS functionalities over the internet, then it comes under the category of WebGIS. Means you are not using any of the software for visualizing the data, for processing the data, or for editing the data. All your GIS tasks are being done on a internet browser like Chrome. In the Chrome itself, you are seeing the data, you are able to add the data over there, you are able to visualize it, pan it, zoom it, do some editing on top of it, then do some processing on top of it. All the tasks are being done over a Internet Explorer like Google Chrome. So that is a WebGIS to be very simple terms. So if we talk it like the formal definition of GIS, WebGIS, it will be like it is a computer software and hardware configuration, okay, that allows sharing of the maps, spatial data, geographical processing operations like buffer analysis, nearest neighborhood analysis, or it can be any point pattern analysis, any kind of, or the spatial autocorrelation, co-kriging, all these geographical processing operations throughout one's own network and beyond. using common web application protocols such as HTTPS and WebSockets. So these are the two internet protocols which makes it possible to perform your GIS task on a Internet Explorer or on a web browser. Now, how it contains and how does it works, that WebGIS? So basically, this WebGIS, it has one GIS server which is identified by a URL. Example, we have created over here https://forestfire.irs.gov.in, or it can be a bhuvan.nrsc.gov.in, it can be google.com. So a URL is required. Okay, so first of all, a GIS server which is identified by the URL, and then we require the client. Your PC, normal PC, it can be a client, it can be a web browser, it can be a desktop application as well, or a mobile application like Google Chrome, QGIS. Now, if you see it here, both Google Chrome as well as QGIS, they are becoming as a client. So your client can be one application. It is not your PC, but an application. Like Google Chrome is one application running on your PC. Similarly, QGIS is another application that is can also become a WebGIS client. It can ask the data from the server for various purposes of GIS. So one server is there, then client is there, then how they will connect, how they will communicate. So there is requirement of a communication protocols also. So it can be via hypertext transfer protocol. This S stands for secured. So a communication protocol is required. Server is there, client is there, communication is there. Then what is the format of the data? So these are the four basic components like server, client, communication, and the format of the data. It is the response that can be HTML, it can be a binary image, XML, GML, or the JSON. These are the 4 5 formats which are you receive as a response from the server at the client end. You are not receiving the data in the physical data in these forms, but the response comes in these particular formats. Or there are some other formats also which are returned by the server. It can be an image format like JPEG format, PNG format, TIFF format. They can also be returned by the by your server. Now, if we talk about the client server architecture here, so there is one client here in any browser is opened over here, or it can be a desktop application like QGIS. It sends the URL, the URL of whom? URL of the server. Now, once that URL is reached its destination, it provides the response. The server sends a HTML page to the client. So this is a very basic flow of the data in a web environment, and it all follows HTTP protocols. Now, if you see it here, a secured one, how to secure that data. So if the client makes a request, there we put one firewall, certain rules are identified for it in the form of an XML document. So these rules decides which data to process and which data to discard. So before reaching the server, these data sets or these requests are filtered at this firewall level, and this has become very important these days. From whom you want to receive the request and from whom you want to discard the request. So sometimes there are the hacking request may also come. Some person is want to hack your PC. So you put one firewall also on top of it. And for that firewall, all the rules are there in the form of a XML document. So what happens inside the server now? Okay, this is the client. This you can see your PC is there. You can be mobile. It can be desktop. Anything. They are making the request. So request goes to this firewall. Once it is cleared by the firewall, it reaches a web server. The first point of contact with the server is a web server. This web server is nothing but a small software which is installed in your PC or in the server PC, you can say, or the server hardware is there, server computation hardware. Over there, one software we install by the name called web server. Example like Apache or IIS, Nginx, there are NX engine. So there are multiple software which makes your hardware available to your clients so that they can receive those requests and put some actions on it and provide a response to the client. So this is all handled by a web server. Now this web server is only for handling, receiving the request and providing the response to the client. Now, suppose you have an application. It can be a GIS application. So it cannot handle the GIS application or any other business application directly from its own end. It requires another another software that is known as application server. You can have a dedicated hardware also for it, or you can install it in a same computing machine as well. That is known by one another software called application server. It can be like in our case, it will be a GIS server basically. And what this application server will takes all the business logic of your application, how it will be processed, what will be processed, and it will produce all those outputs and it will give it to the web server, and then this web server gives it to the client in the form of an HTML. Now from where it will get the data? It can get the data from some database server. This is again a secure mechanism of saving the data. You save the data in a data server over here. Once the data is the data server, we can implement security mechanisms also to into it. Who can access it? How much amount of data he can access? So all those restrictions can be put on this data server. Directly you don't put the file, you just put the data on a data server over here. Then rules can also be defined over here. So this is the basic we can say architecture of a client server application or a web application. What advantage it has now? The advantage is data protection. With access control enforced by the security policies, you can inbuild security policies which will allow to protect your data. It is also platform agnostic. Like client and server can have different operating system. You are having, let us say, Linux operating system, whereas the server is having some Windows operating system. So still they are able to interact with each other, or it can be vice versa, Windows at your client side and Linux at the server side. So still they will be able to interact with each other. This all becomes possible because of those standard communication mechanisms. Okay, so it also handles a large user base that can be addressed at the same time. Only limitation is of security and overloading also. Like suppose multiple requests are coming, thousands of requests are coming at that time, overloading and denial of services kind of or problems may arise due to a very large number of user requests. Now, if it, I was just telling about what is a web server there, the first component, the first point of interaction with the client request, web server. Okay, so it is a software basically and a hardware that uses HTTP protocol and other protocol to respond to client request made over a world wide web over there. Okay, so popularly used web servers are Apache HTTP server. It is free and open source. It is most widely used software. Apache HTTP server. Similarly, we have Apache Tomcat server also, which is also free and open source. Microsoft Internet Information System IIS. It is a proprietary. It comes along with the Microsoft operating system. Then we have Engine X. It is also free and open source. Now this is the latest web server which is also capable of handling multiple requested load sharing can be done on top of this Engine X web server. Light HTTP, free and open source. If very limited number of users are there, then you can have a very lightweight web server also installed. Sun Java web server is again a very Java based web server is also there. Now which one to select? So how well it works with operating system? You have to see which web server works good with which operating system. So what operating system you are. So that again defines which one to select. Now its ability to handle the server side programming, which kind of programming languages they are able to handle, like Python, whether they are able to handle or not, or PHP, Java, or which kind of backend programming language they are able to handle. So that also decides which one you have to select. Uh, Security characteristics, how much security you want in your web server, the publishing and the search engine, and site building tools also sometimes they also comes with it. So these are some of the criteria which decide which web server you want to deploy for your application. Now, when we talk about the WebGIS architecture, only thing is that all things remain same. In For this application server, we put one GIS or a map server, one more application over here by the name called GIS or the map server. So there are numerous. I will be telling you like one example. I will take you here. That is Geo server. Geo server is one very popular GIS server which handles all those GIS processing inside a web server. Now, components of WebGIS, if we talk GIS on the internet, we can say web client. This is your PC basically, and this is an external internet. All the communication you are making through your, it can be your mobile communication or any kind of internet you are using over here that comes over here. Then when you are making a request through this atmosphere, through this internet, it directly goes to a firewall is not mentioned over here, but there is one firewall also. So the first point of contact will be your web server. Then it goes to the application server that is known as a geospatial server. Now this geospatial server can fetch the data either from a file server or from a database server. Okay, both can be there because sometimes I don't have the mechanism to put my files into a database. So directly those files also I can put it over here. So like save file, one popular format is there, or let us say grid file, like your geotiff file. So those files can be put separately also, apart from keeping it on a database server. And this is only the inside the internal network. And then we can have an administrator or the internal client application here, from which we are generating the data, and that is being published to this geospatial server. Now we will see one example also where you develop your application over here while fetching the data from these two components, publish it on geospatial server, and then through web server it goes to the web clients as well. So that the architecture very simple it becomes. Now, if we talk about a web map or a WebGIS map, so what does it contain? Basic elements of a web map. It can be a web application. So first of all, you require a web application, because in that web application you can add multiple things. You can put one introductory part, one GIS visualizer, some processing task. So you can segregate that web application. Then it can have digital base maps also. Those reference maps can be put over there. There are certain maps which are used only for the reference purpose. So they are called as a digital base maps, like OpenStreetMap can act as a base map only. Similarly, we can also have operational layer, that what the layer on which you are going to work. It can be a land use map, it can be some soil map, or it can be some watershed boundaries map, or sorry, water bodies map is there. So on top of which you try to perform any sort of application, like you want to perform a multi-criteria decision analysis. Example, we will take it like your GIS workflow is like you want to find out which are the potential sites for groundwater prospects, where I can have those groundwater prospect wells can be dug. Those you want to find it out. So for that you may be having certain criteria layers also, like geomorphology layer. It can be a soil layer. It can be a land use map. It can be a existing wells map also over there, or water boundaries maps you can have. So these criteria once combined together, they will generate your groundwater prospect map. So those are the criteria maps, or those like maps, they are known as operational layers, which are used for your accomplishing the geospatial task. Okay, they are called as an operational layer. Then there are some tasks and tools, means algorithm is there required, which algorithms you want to put it over there. What are some tools are there? Navigation tools like zoom in, zoom out, and you want to put the map into a 3D form or into a 2D form. So those all can be done. One or more geodatabase is also required. Okay, so one example I have written over here, base map, your OpenStreetMap or the Google Maps images, they can act as a base map. Whereas thematic map, I already told you, land use maps or any other map, interactive elements can be pan, zoom, tilt, pop up, etc. It can be many. Now, what advantage it has? It is again the same advantages of the client GIS server or the client server architecture. It have a large number of user base. It can reach global at the same time. Better cross-platform compatibility, irrespective of which computer you are having and which kind of operating system you are running. So it can work on all those computers. One for you have created for one, and you run it on multiple PCs. So cross-platform compatibility is there. Low cost as averaged by the number of users. The number of users you are accessing through that WebGIS. That the cost is very less as compared to that part. Easy to use, unified updates. Whatever updates you are making at the server side, the same updates are visible to all the users at the same time. Applications are also very diverse here. So this all has become possible due to this concept called Web 2.0. I think in the first lecture also it was covered. So I will add one more into it, that is called Geography 2.0. So if we talk about Web 2.0 technology, it is referred as an interactive web application with public participation. Means your internet is acting as a platform for data dissemination and data contribution also. You can contribute the data also as well with public participation, which allows participatory information sharing, interoperability, user-centered design, collaboration on the World Wide Web. And if you integrate the GIS data application with Web 2.0, then I am calling it as Geo Web 2.0 or Geography 2.0 as well. Now, if you talk what kind of task I can do on a WebGIS, so you can do the visualization, both 2D and 3D can be done over there. Data services, any kind of data can be accessed over there. It can be raster data, vector data in the native formats as well as in some restricted formats also, portrayal format also. Like you want to show the data to the user, but you don't want that user to download that data. So that kind of restrictions you can put it over there. How it will be possible? You have a save file. Now you don't want that user to download that save file. Okay, some boundary file you are having. So what you can do, you can create its snapshots, image file out of it, and that can be visualized by the user. So he will be only seeing those JPEG or the snapshot files, but your data will be safe at the server side. But if you want to give the data also, then that is also possible over there. So all that data service is possible over there. Editing, you can allow the user for editing on the web, you can do geo processing, even this is also possible, and that multi-criteria analysis I told you, so all those can be performed. Cataloging also, catalog service, what kind of data I am storing at my end. So so these all are possible inside a geo inside a WebGIS environment. So now typical WebGIS architecture, if we talk implementation point of view, how we will implement it. This is your client side. You can have a QGIS software over there. There is one leaflet library. There are multiple clients. It can be a mobile, it can be a desktop. Then they make a request through these systems, through this client, and these requests can be a WMS, WFS, or WCS. WMS means Web Map Service. WFS, the Web Feature Service, Web Coverage Service. It can be Web Processing Service also, PS. Okay, so all these requests are in these formats only. So special requests are made, and once they reach at the server side, if you tell here, I told you there is first point of contact will be a web server. So this is your web server. Now it can be an Apache, Tomcat, anything. Okay, it can be a Apache HTTP server or a Apache Tomcat server as well. So once it reaches it, then there are in that same server software hardware, we have another application called GIS server. Now there are two GIS server. This is application server basically. First you see here it is a geo server, and it can be a map server also, any one of them, not both, or sometimes you can have both also. As from our experience, we have found that if your size of the data is very heavy and it is in the raster format, then we have always going for the map server. Whereas if our data is lightweight and it is lesser in the size, then we have chosen for our application geo server. But it depends again what kind of data quantity data volume you are having with you. So that again you can experiment with them, and then particularly you can decide upon which one you have to use, either both or a single one also. So now we can have at the same time we can have here a GIS database also. Example is PostGIS. One, you can put all your data into a database management system, and then it will go to a GIS server, from GIS server to web server, and then as a response it goes back to this client. It can be QGIS, it can be a open layer, leaflet, anything. Now, I was talking about the data in the form of a service now. So whenever we are basically when we are talking about the WebGIS, so most of the time we say that we are handling the data in the form of a service only. Like in my second in the second lecture in this series, we have seen that how the land use map we were able to see from Bhuvan into my QGIS. So all that has become possible because of this service oriented architecture. So that is same with the true for the GIS as well. So here we can have a data services in the form of feature services. It can be a raster data, it can be a vector data, it can be a data from a sensor also, or it can be data from another website as well. Geosync, it can be a grid coverage. So these all are under the data services, this architecture here, data services. Then I can have publishing also in the form of a portrayal services. Portrayal means I want to just show the data to the user. I don't want them to download it fully. So there are mechanism for putting the for publishing the data as a portrayal services. We can also have the processing services as well. It can be a web processing services, coordinate transformation services, geocoder, reverse geocoding, dictionary services. So all these are standards are being had been developed, and they help us to perform the geoprocessing on web. And similarly we have encoding also, like you have one India boundary map, state boundary map, and you want different color for different states. So that symbology colors, so they all color coding, they are they it become possible due to this encoding services, which I was telling to you, that was SLD, style layer descriptor. Apart from that, there are other encoding services also. So similarly, for the catalog also, it can be a service catalog, it can be a style catalog, it can be a device catalog, and any other kind of catalog can be done over there. And once when it is published, then it can be bind at the client end also. Map viewer client, it can be image exploitation value added client, sensor web enablement client, it can be symbol management client. So these is the complete architecture of WebGIS in terms of services, in terms of web services. So if we talk about the specific definition of a web service, you can say it is a piece of code that runs on the server and can perform some actions in response to a client request. So there is one web service which is there in the server in your server hardware. So what it will do, it will perform some code in the server itself, and it will give it as a response to the client whenever a client makes any request. So GIS services are self-contained, self-described modular component of geospatial application, which can be accessed through standard protocols. If you say some examples, so a web service, I'm talking about a GIS web service, it might receive some bounding box coordinates and an image format from the client, draw a map, and then send the image back to the client. So a request is coming from there as a bounding box, a format of the image, from which format I want it. Then what it will do, it will draw an image and then it will send it back to the client. So client is only sending the bounding boxes and the format. The rest work your web service is doing, fetching the data or drawing the image and then giving it back to the client. Another type of web service, it might receive some vector feature coordinates, calculate an intersection of those features, and then send back to the client the coordinates of the intersecting feature. Means your client is sending, I want the intersection of one land use map and the slope map. So what it will do at the server end, that web service will perform the intersection operation, and once the outputs are result, that common features, they are sent back to the client. I am not performing that intersection. It can be intersection, it can be union, it can be identity, any kind of operation they are done with the help of a web service basically. So what are the important consideration for a web service? So you should remember which format you are taking from the server. You have to define it yourself, XML or JSON. Okay, and which kind of protocol is HTTP or HTTPS? Currently, most of the platforms they are supporting HTTPS. That is a secured protocol basically. If we talk about difference between a website and a web service, so your website, it provides HTML pages and forms for human users to navigate and perform functions. Which kind of functions? Like searching, shopping, interaction. Now, example can be a google.com front-end user interface to a browser. There is one front-end user interface as well as like a browser. Whereas web services, they are not the websites operations that can handle or to return the information. They are basically some operations. They can be invoked automatically through a program. One program you are writing, it will invoke it automatically. It is publicly available and standardized for use by all the programmers. Examples I have seen like Bhuvan thematic map service, we have seen it. So now there is one geospatial consortium I told you earlier also, that is known as OGC. So these particular OGCs, it develops standards for the geospatial web services. So around it is an international consortium of more than 500 plus organizations. Okay, and they have published more than 200,000 OGC web services deployed across the web for meeting the requirement of different web applications. So more than 200,000 web services have been deployed. Standards have been made for them. So any kind of requirement is there, there is one standard for it. Suppose you want a vector file you are having, because most of the time we are having only a vector file with me, and I want one standard for it, how to transport it or how to handle this vector file or save file in a web environment. So for that standards have been developed. Suppose you have a TIFF file, for that also standards have been developed. Some of the applications, some of the web services are like web map services is one stand name. This is basically the name of a web service. Web map service which basically handles the raster and the vector data in the form of a JPEG image only. Means your save file portrayal service only, snapshot kind of thing. So your WMS will not show any particular data, but it will only show the snapshot, but with geographical coordinates as well. Okay, and it can also display the properties of the features as well. What are the attributes of that feature? That can also be displayed, but only as a snapshot. Similarly, if you want to give the actual data to the user, the vector file, so we have web feature services. Suppose you are handling the image file or DEM or digital elevation model, it can be a thematic map. They can also be given as a web coverage services processing through WPS, that is web processing service you can perform. And for this web processing service, very popular languages over internet are the Python programming language and the R programming language, and Java is also there, but I have seen that most popular are Python and R programming languages only for developing your algorithm as a web processing services. So if we talk about web map service, it is an HTTPS interface for requesting geo-registered map images, and it request and response. What is the request for it? A WMS request defines the geographical layer and area of interest to be processed. So this is your you are providing the area of interest and which layer you want, name of the layer and area of interest of which area you want it. That is request, and response is one or more geo-registered maps returned as JPEG or PNG only. Okay. Similarly, for the web feature services, again, it has the same things, but it supports insert, update, delete, lock, query, and discovery operations on geographical features. Whereas for the web coverage services, the term grid coverage typically referred to as satellite images, digital layer photographs, digital elevation models, and many more. So the three methods which have been defined for a web map service are get capability. It describes all the capabilities and available layers over there. Then another method is get map. These are the functions or the operations which are available directly written for your web map service. Get map, it generates a map based on the input parameters. And get feature info, it gets the attributes for a specified feature. What are the attributes behind it? So, this query this third method is available with queryable WMS services basically. If we talk, let us take this example basically web map service. I will show you one small example of a web map service. Let me open this QGIS. We have seen it earlier. So if you see it here at the top here, layer, and then you can have it here add. I am not having the data with me. I want the data from internet. Add WMS. Here one option is there, web map service. Just click on this particular portion and then it will show it to you over here. Then you can create one connection. Already we have created one connection called Bhuvan in the previous lecture. If you see it here, I will just edit it. So you say one name I have given to it, and this is the name of the URL which we have taken from the site of Bhuvan. Okay, and it is saved, and then when we do the connect, so it will call the get capability method. When you are clicking this connect, what it is doing basically, the method I told you over here, get capability. This, it is showing me what are the capabilities of this server. So there are numerous capabilities, not only one layer. I wanted the land use map, but it has a huge amount of capabilities with it. So these are visible over here. Suppose you see here edit, I will just take here, I will just copy it here, Control C, and if I go to the browser, any browser you just go, and I try to see it here, Control V, and method I will write RESPON response, RESPON as a response equal to get BILITIES, get capabilities. So it will return one XML document to you. Right now it is CAPA capability, spelling mistake maybe there, response equal to get cap method. Sorry. So if I talk over here, yes, response equal to get capabilities. It is not able to fetch it from there, but otherwise you get just like this QGIS. This is one client basically. Our browser is another client, so it is able to list all the layers over here, all the capabilities of that server. So I am interested in one land use map of UK, Uttarakhand. Let us say UK. You just type it here, and then LULC. I will type LULC. And then if you see here, there are numerous layers here, LULC, CG, and name. You should know what is the name of your layer. So these names are also defined by you only. Okay, CH. So UK I will take here. It will be at the bottom somewhere. SHTP, LULC 50K. And you can take it from here. LULC MN, name is written there. LULC map, any you can take it. Let us take any one layer. I will take it here from Uttarakhand only, or we can just check it also here over. I will go to this BHUVAN Bhuvan dot nrsc.gov.in. This is one server Bhuvan dot nrsc.gov.in, and then if you see it here, that is a thematic service there. Now I was just trying to find out what is the layer for me. I will just click it here. They are available as a web service. So land use map I want of 2015-16, and then I'm selecting one state called Uttarakhand, then web service. So you see it here. This is the URL. I was telling to you the first component is the URL. This is your URL. This I have copied over there. This is the name of the layer basically. This is the layer. So this is the data basically. Copy it here, and then you can try to search it from here. Control V, then it will display directly over here. 15-16, and then add, and it is able to fetch it here. Close. So your map is displayed here. Okay. The same map you can display in your browser also. Okay. So for that you have to do just simply here properties, just check it here, and it will show you the complete request here. Information, just click at the top here. Information, it is little bit computer is hanged. Okay, information, and if you see it here, this is showing the complete list of it here. If you see here, I think it is visible to you, the name of the URL, and then legend, CRS, feature count, format, layer, and all these things are visible to you at this particular place. Source, entire source. So this you can take it to directly to the web server in your browser also, from there which you can display it directly. If let us me copy, this is a get capabilities URL. Let us say control this copy from here, and we will try to find it out here. Control V. Okay, RESPON, response equal to get capabilities. It is okay, not able to display it over here. Anyway, so this but it can be displayed on a on your browser as well. Let me copy this one, this browser here. This is the complete URL. Control C, and then I will try to use it here directly in my web application. So this is your legend basically. Legend it is able to display here. So this is nothing but coming from directly from the from that Bhuvan server. So this is the URL for the legend. Similarly, you have the URL for your layer as also. It is somewhere displayed over here only. Mm, get map. This is this particular get graphic map. So from there you can use it, and your map will be displayed to you. So I will just come back to it. So this was one example, get capability, get map, and get feature info also. So in QGIS, if we talk here, let me try to find it out here. Click it here. So it will show me the this is particularly HTML, or you can have a text also. Let me put it text. So if you see here, or it can be a feature, uh, barren land or description one. So let what is this yellow basically? I want to know. Just click on it, and it will show it is a built up or it is a description built up rural, and then Haridwar. I have might have clicked on the red portion. If you click on this exactly on the yellow color, in yellow color it will show it is basically agriculture. And if you want to show what is this pink color, so what is doing basically, it is a scrub land. So it is calling this third method called get feature info. Get capability for the list of all the layers, get map it is displaying it, and get feature info it is displaying the properties or the attributes of the specified feature. Now, this is one example over here. And then if we talk about the web feature services, web feature, actual data I want. So these web feature services, they are not available directly in Bhuvan. So for that, I have another link. I will just show you. So it is for the vector services, for the vector data set. So it has three main functions. Get capability, it is the same only. Describe feature type, and then get feature. So these are the three methods which are available for the web feature service standard. The example is, let us go to this example basically. Let us say I have, this is one URL which we have taken for the feature service. Now I want just you see it here, village level geospatial socioeconomic data for the state of Uttarakhand. Whether it is available? Yes, it is available as a data also from where you can download it. Okay, as directly data you can download. So let us try to create it also here. Layer, add layer. Now I want add WFS layer. Okay, I will create one new layer name. I will give it to here WFS WFS dash Uttarakhand UK. Okay, some name I am giving to it. URL I am just pasting it over here. Geo server. Then now if you see in the URL itself, Geo server is written over here. So they have all published it in a Geo server. Okay, and then just connect it. So protocol is not defined. Edit. So HTTPS. I think it is creating some problem. This HTTPS. Okay, so this one I will take. That was the service URL. Get capability is this one basically. So URL you have to be very careful which URL you are using. So this is that URL. I will just say OK and then connect it. Now you see it has connected. All the layers are there. Now I want the village level socioeconomic data for Uttarakhand. I will not take Uttarakhand. Let us take one. Okay, Uttarakhand is a bigger state. I was Tripura. I will take it. Village level geospatial socioeconomic data. If you can see the capability, this all has come from the get capability method. So all the requests, all the capabilities of that server are displayed over here. So you can just see what the things are there. A village level socioeconomic map of West Bengal, Uttarakhand, UP, Tamil Nadu, Sikkim, all the things are there in this particular server. So if I select of Tripura, then add and then close it. So you can just see here, it will display. I will switch it off and right click, zoom to layer. So it will display. You can see it is loading those features. Okay, all the boundaries have come. Now let us take for Uttarakhand also, and for quickly it has come up. Add WFS, and then I want for Uttarakhand. Add and then close. So it will add for Uttarakhand also. Right click and zoom to layer. So slowly it will create it. It is taking a longer time. Yes, you can see it here because the number of polygons are more in Uttarakhand as compared to Tripura. So let us take some time for it also. It will display all those layers over here. Okay. So this you had started fetching all the features from there. Now I will show you the difference of this WFS and WMS both. So we have the WMS of Uttarakhand land use map, and we have the WFS of village boundaries of Uttarakhand. So what is the difference between them? So basically, then we will just check one WCS also, the third component of WebGIS. Let it get displayed over there. It is taking a little bit of time. Okay, so this is your village boundaries displayed over there. I will also open the WMS as well. So now both the layers are there. If I switch it off here, so you have WMS and this is your WFS. You see here, right click, it has all the attributes, open attribute table. So it will just load it, all the attributes in a tabular form as well. Whereas this is not true for WMS. For WFS, we can see both the geometry as well as the attributes. But in case of WMS, we are seeing only the snapshot of the data sets with geometric, with the geocoding as well as with some attribute information on click of a feature. If you are clicking on a particular feature, it will give you those attributes of that, but it will not give you in a tabular form. So here it will take a little bit of time because number of polygons are more over there. It will load it here. And once it is loaded, so we can just go through it. Acha, this village level boundary, by the time you can go from where I am getting it. I have given it the link in my slide, which I will share with you. But apart from that, also, you can quickly search. There is one website called GeoSeer. Okay, just click on this GeoSeer. So if you click on GeoSeer, it is a catalog service, you can say here, which is giving you most of the data sets are available over here. I am saying here you Uttarakhand, 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 suppose. What all data are available over here? Uttarakhand. So it will show me village population, or you can say here, though so many layers are available and they are available as a WFS, WMS, and these all stand in the standard form that data is available over here. There are numerous second also, village wise also WMS. This is for, let us say, for first I will talk about here village population, geoinfo AIT, geoinfo AIT. Again here, this is the URL for it, and what capabilities for district wise also, Champawat district, Nainital district. So this way it has been published, it is the links are available in this particular portal. You can utilize it, Uttarakhand, or you can have some other states also. I want some coverage data, so you can say COVERAG WCS. You can type it over here, WCS, web coverage service. So it will show you the list of some web coverage services as well. I will say of INDIA India. Okay, WCS India. So you can see it here. So many data sets are footprints, maps are available there. So I am just aware KERAL, Kerala. I have just searched it in the morning as well. So Kerala DM, it is also available here. Just click on this particular portion. This is your get capability request. Just copy it here from this. Control C. Here it has also loaded. Now if you see, you are getting all the attributes, like what is the state, along with all the attributes, main workers, this census data of 2001. It is all along with all the attributes, it is available. Just try to make use of it. I will leave this slide, all this link with you, and you have to just follow the instructions which I have given over here. So I am having attributes as well. Whereas for this WMS, it does not have that attribute information over here. The label is not there. Now, if you see here, right click, export layer, save feature as, you can save it as a save file also. It is allowing you to save all the data with you, not only displaying, but getting the data as well. Whereas in case of this WMS, you can export it. It is showing some GeoTIFF format, but usually it does not retains the uh, actual data set while exporting it to your local PC. Now let us go to WCS also, the third one here. I will say add layer, add WCS. Okay, so there I will give one new name to it. DEM WCS, I will write here WCS dash KERAL Kerala, and then the URL is dem. Okay, and then if I say OK, and then it will list it here. Just take a little bit time here. New existing WCS connection. Okay, Control V, and name I have given to it WCS. WCS. This is going to give me the raster data also, and if I select it here, it will get listed in my drop down menu over here, and then it can be used here. Again, I will see layer, add layer, WCS layer. Let us take it here again, and then if I create it a new one, Control V, and then WCS. Okay, should be overwritten. Existing connection, yes, please overwrite it. It is not stored. No, it is not listing it over here. Let me check it again. Add layer, add WCS layer. some temporary issue may be there, but usually it will load that server and all the capabilities will be listed over here, and then accordingly you can add it to your mapping canvas over here. So this was about some small properties I have shown you. One example also I have given you of WFS. Similarly, we have for the WCS three methods are there: get capability, describe coverage, and get coverage also. So get capability is same. It will list all the capabilities of the server to you. From that, you select your own, and then you display it in your WGS in your map canvas. It can be a QGIS or a web browser as well. So we have seen if you categorize them, it can be a data service, portrayal service, or any other service. It can be processing, encoding services. This already I have covered. So how to publish this data now? The question arises. Okay, these websites are there. Bhuvan is there, and one GeoSeer is there. So they have all published their data. Now you want to publish your own data. So for that, there are certain tools here. Like one of the very popular one I told you, GeoServer. It can be a UMN map server, ISRO ArcGIS server, or the Apollo server. There are others also, but these are very popular. These two are the proprietary, whereas the first two one are the free and open source. You try to download it and try to publish your data as a WebGIS environment. In GeoServer, it is a Java based basically. And if you talk about the map server, if you are comfortable with the PHP kind of thing, so for that you basically use uh, this map server as well. Now, if examples of web mapping APIs, there are certain APIs also which are used. This also you should be aware. You should know, learn about these things like OpenLayer, Leaflet, D3, Polymaps, Modest Maps. So these are some of the mapping APIs for building your browser-based apps with HTML and JavaScript. Now, once your data is published, now along with the URL you want to store it like a Bhuvan kind of thing. So you can make use of these libraries. You should be thorough with HTML and JavaScript. Once you are aware of JavaScript and HTML languages, then you can make use of these additional libraries as well. Okay, these are basically JavaScript libraries, this OpenLayer and Leaflet, and which allows you to create interactive maps as well. One example, this I will leave for you to read it, or we can just see it here also. If I just copy it here, you can see through Leaflet. I am trying to use. Uh, you can use any portal here. Let me say a Notepad. So in Notepad, if I am saying it here, you can directly save it, file, save as, and then D drive. I can save the map as test dot html. You save it, then your data will be created, save. So once it is created, now you can open it as well as desktop. So if you see it here, I have just created one test over there. This is the test.html. I will save it again here, file, save as. I will save it in D drive. It is basically saved. So I will go to the D drive here. And then if you see this is test here, right click and try to open with Google Chrome. Then you can see your map is in the browser as well. You can do all those functionalities over here like this. You can your web page you can create your for your own, and these layers can be added on there. You can create your WebGIS application, and you can fetch the data sets from multiple sources like this. One example I have given you. In more details, if we have one WebGIS course also, wherein we will tell you how to build it actually, how to what is the meaning of all those codes. If you see it here, one small example, one line of code, if I will explain you here, you can see here, this is WMS layer. So here I am giving the URL for the layer name, and I am giving the name of the name of the layer which I am using. And there are certain small methods which are available in the leaflet, and then that can be added to a mapping canvas as well. So this is one example through QGIS as well as example through a leaflet as well, a programming language. Through a browser, we can just see it here. So these applications are there. Now, how can I combine the data from each of these sources to answer my question? Some data is over here, some data is in another portal, some population dot data in some other country. If I want to fetch the data from all those things, so that is all possible because these data sets are most of the time in the web environment, they are available as a web service or as an API. So you can combine all these APIs into a single portal, and your questions can be answered from that by processing all those data sets from these different web portals. Now you can have a 3D virtual reality in WebGIS environment is also an emerging um, trend in the current scenario. And what all this WebGIS it can be used. It can be used for collaborative mapping and data services, and it like OpenStreetMap. This is a very good example of collaborative mapping or a WebGIS based environment. I have demonstrated this previously also. And national spatial data infrastructure. This can also be created if you see the central government organization, state government organization, universities, NGOs, other organizations, they all can create a spatial infrastructure, data infrastructure, and that can be used by the various users within that organization. From a single source, the data can be used by all of them. Um, some of the web application I will try to show you here, which we have developed at IRS. Example, if you take here forest fire one forest fire dot IIRS dot gov dot in. If I click it here, if you see one portal we have developed at IRS, if you can see here, we are able to see the data from this is the data from Bhuvan, the satellite image from Bhuvan it is coming. And at the back end, if you see here, this is the Bing map, and from two layers we have combined it here. And apart from that, district boundaries of India, you can just display it over beat boundaries. These are the administrative boundaries. And then if we talk about the forest fire maps here, daily forest fire maps we are creating over here. So forest fire vulnerability map, it is published there, and we are just consuming this in a WebGIS portal, in this particular WebGIS portal. And if you see it here, weather info also, so it will say for a particular place what is the weather over there. This is coming from open weather map, another portal which gives the data in the form of a web services. And another specialty of this, we can combine it together. 2D maps as well as 3D also can be visualized over here. So if I see it over here, latest base map, I am taking of the Bing map, Bhuvan map I will display, switch it off. So in the same environment, I am able to see both 2D as well as 3D. And this is suppose this is one Dehradun area, and this is some hilly terrain, so I can convert it directly to a 3D mode also. So this all can be possible through a single platform here. So here now I want to display some map on top of it, forest fire map if I am saying here, forest fire vulnerability map Uttarakhand, so it will display it over here on this 3D platform as well. Although the resolution is different, but you can just switch now here. This has the facility of the opacity, so you can do all those functionalities also here over here. So this, if you are able to see it here, this is the forest land here, and it is showing some moderate high vulnerability over here. So this is one particular example of WebGIS which we have developed at IIRS. Both multiple sources data is integrated into it, as well as the platform of both 2D and 3D is into a same one. So this is in full screen mode over here. And again, I will go to 2D and let us move it to, we can, on the click of a mouse, you can switch from a 2D to 3D environment. Weather information, you can just see it over here. So this, some other WebGIS course is there. At that time, we can demonstrate how you can develop your own any geospatial workflow if you want to implement through a this WebGIS environment, how you can do it. So either you, we have our courses also of WebGIS. You can attend those courses. Lectures are available on the internet, and then follow those instructions over there. Or otherwise, we also conduct it on regular basis. You keep following this IIRS EduSet network. If it is available there, then you can be benefited from that part as well. Today is only an introductory part. what is the strength of WebGIS basically. So with this, I come to an end. Hope I am able to communicate you about the what is WebGIS, what are the features, and how what are the various components of a WebGIS, and what are all knowledge is required to in order to develop a WebGIS application of your own. Thank you very much. I will break for 5 minutes and then we can take quickly. We will take some 2-3 questions as well. Thank you very much.